I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover the fuzz testing settings establishment activity. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training, and additionally that you've completed the requirements taxonomy, security requirements, secure design principles, apply secure design, threat prioritization, secure settings, secure coding, and fuzz testing overview trainings. This training will cover the fuzz testing established settings activity. Before getting into settings establishment, let's briefly review where it fits in the overall fuzz testing process. Here's the fuzz testing process that we've previously covered in the fuzz testing overview training. Our focus for this training will be on the first activity, that is settings establishment. Within the settings establishment activity, the development SME, fuzz testing SME, and DevOps SME take the element, the build file, and the fuzz testing framework documentation, and establish a set of element-specific settings to be used for fuzz testing. These are put into an updated build file and produce a security options qualifications report. If this diagram seems really information dense, that's because this is an encapsulation of the secure settings process. Let's review that process. The secure settings process is comprised of 4 activities. These are identifying options relevant to security, categorizing these options, selecting which ones are going to be used for each element, and finally, applying those options to the build system for that element. Now let's briefly review the materials that provide both documentation and training for how the secure settings activities should be undertaken. First, we have the secure settings overview training video, which complements the secure settings document secondary document and provides an overview of the secure settings process described in the AVCDL primary document. The secure settings identify options training goes along with the secure settings identify options procedure. It works its way through an example using GCC as a basis, covering how one would take a tool and extract the various options from it. The secure settings categorize options training goes along with the secure settings categorize options procedure. It extends the example from the identify options training and covers how one might create severity categories and categorize the identified options so that they can be processed later. The secure settings select options training goes along with the secure settings select options procedure. It continues extending the example from the previous training and addresses how options are selected for application to a specific element of the system by the cybersecurity and development SMEs. Finally, the secure settings apply options training goes along with the secure settings apply options procedure. The focus here is on the DevOps SME, tasked with taking options selected for application to a particular element and making the adjustments to the build system to integrate these options. Unlike most of the AVCDL processes, which are able to directly apply the secure settings process in order to establish the settings for a particular tool to be used, with fuzz testing we're dealing not with a specific tool, but with a set of frameworks. The way we're going to approach this is slightly different. Let's go back to the secure settings process and see how we're going to customize it for use with fuzz testing. Here again is the secure settings process. What we're going to do is customize the first 2 processes of identification of the options and categorization of the options. Zooming in on those, from a fuzz testing standpoint, when we talk about the tool documentation, we're talking about the documentation of the fuzz testing framework that we're considering here. And our identification of options is in the context required in order to make those things work. That gives us a set of options from which we can pick to do our fuzz testing. In our next step of categorization, what we're talking about for categories are the use cases. The fuzz testing use cases are documented and a use case is assigned to each of the framework options. This yields our categorized options. Now let's work our way through an example of fuzz testing framework option identification and categorization. We'll be using the AVCDL Fuzz Testing Framework Options template, which is described in the Fuzz Testing Established Settings Procedure tertiary document that goes along with this training. It's important to note that this is just one mechanism for documenting this information. There are any number of ways this information could be documented. In an ideal world, you'd use a database to store this information both across frameworks and versions of frameworks. For our example, we record the SME who's performing this activity, the date that the document was updated, and finally, a monotonic and increasing version number. In the references sheet, what we have are the name, description, and location of the material we use to construct the information in the remainder of the workbook. Here, since we're dealing with fuzz testing frameworks, we're going to make sure that we enumerate all of those frameworks and provide the relevant references to them. Additionally, since we're going to be doing categorization, we need to include any relevant references that we use in order to inform that activity. For the options themselves, we include the following information: a unique identifier, the option name, which should also be unique, the name of the framework, the version of the framework, the features of the framework relevant to the option. This is important because frameworks typically provide more features than needed for any individual use case. Next, we have the operating system for the option. If you have multiple operating systems that are going to be utilized, you should have an option for each. The same is true for our next item, which is the build system that's being used. We then have the compiler, a minimum compiler version, and the compiler options required by the framework option. Next is the category, which we'll get to in a bit, and a notes field. Looking at the first two entries, we have FWHFP Linux GCC 1 and FWHFP Linux GCC 2. What differentiates these is whether we're using GCC 6 and later or GCC 8 and later. The compiler options change, but everything else is the same. Both use Hong Fuzz version 2.6 with identical features targeted for Linux, built using Bazel and managed by CI Fuzz. Because the compilers, depending on the version, have different compiler options, we need to provide those as different line items so that when we do the next secure settings activity following identification and categorization, that is the selection of the options specific to the elements under consideration, we can select those most appropriate to the element's particular build configuration. Contrast these with FW Fuzz Test Linux Clang. We see that the option name is simply Fuzz Test because it has no variants. You'll notice that there are three different fuzz testing frameworks here: Hong Fuzz, Fuzz Test, and finally CyberFuzz. Remember that you need not restrict your considerations to a single framework. So this is how you approach enumerating fuzz testing framework options. The important thing is that you enumerate all of them so that you can be able to make appropriate selections for the elements under consideration. This brings us to the next secure settings activity, which is that of categorization. To handle that, we use the category sheet. We're going to consider the various use cases which represent the categories we use in the context of the secure settings process. As usual, we have a unique ID, the name of the category, which is also unique, and since this category is going to be used to auto-populate the option sheet, we want these to be both concise and clear. Here, you see we have two general categories, one for source fuzz testing and the other for binary fuzz testing. We also have two specialized ones, one that's dealing with the CanFD protocol against a binary, and UDS protocol also against a binary. Next, we provide a description which is as detailed as necessary so that we understand the use case. Next, we have any qualifications which apply to the category. These answer the question, what are the limitations imposed by this particular use case? Finally, we have a notes field. The last step in our categorization activity is to return to the option sheet and, using the now populated category list, select the appropriate category for each of the options that we've enumerated. As you can see here, the first three are all general source options. The next two are general binary ones. Next is another general source one, this time for the fuzz test framework. And the last two are the two specialized ones. One is CanFD binary being used for CanFD analysis, and the other UDS binary being used for UDS analysis. With the options sheet completed, we've addressed the first two of the 4 secure settings activities. The last 2 activities of selecting the options that we're going to use for the element and applying those options are performed as specified in the secure settings select options and apply options procedures. Since the secure settings process activities speak in general, let's talk about the specific things we need to consider when establishing the fuzz testing framework settings. Aside from the typical, is this element cybersecurity relevant question when dealing with particular tools and settings, there are 3 considerations when dealing with the fuzz testing frameworks to be attached to various elements. This is because fuzz testing is part of the test suite. And so first we need to consider the execution time impact, because the build system may be time-bounded, and the addition of fuzz testing may well exceed any time bounding established by the build process. We need to evaluate this before we recommend any option or framework for use with a particular element. The second is very much akin to the first, and that is a consideration of the footprint. This may be the overall code size impact, which is a concern when dealing with embedded systems where you have hard limits compared to when you're dealing with a desktop or server class machine. Beyond the footprint of the code, you may also have data memory footprint considerations. Are you able to fit all of the necessary data for the test into memory to be able to execute it efficiently and effectively? Keep in mind that in real-time systems, when using virtual paging, you have to take into consideration the memory footprint and the possible adverse effects of memory thrashing. Finally, we want to consider isolation of the various tests. Because fuzz testing is usually performed by taking a corpus of known good inputs and mutating them, you need to ensure that this is being done in a way that allows you to be able to reproduce the results should an error condition occur. Additionally, having fewer variables changing for a given run of a particular test is always desirable. That covers fuzz testing settings establishment. Let's look at a summary. When implementing settings establishment for fuzz testing frameworks, identify the framework to be used, categorize the options, enumerate the use cases, scope the frameworks to be used based on the option applicable to the element, update the build to incorporate the particular frameworks and any settings changes needed, report the changes that we make to the build settings, and remember that when performing fuzz testing in a cybersecurity context, to keep cybersecurity relevancy front of mind. The materials that were used to cover this example are in the locations shown here. It's important to note that the workbooks include all sheets covered in this training. For additional information and to get a more in-depth set of references, the Fuzz Testing Established Settings Procedure tertiary document is available in the AVCDL GitHub repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. With this training complete, if you've completed the other trainings covering the fuzz testing process activities, you can proceed to the other trainings at this level. These include static analysis, dynamic analysis, and secure code review. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL GitHub repository.